Hello everybody, and welcome to the showcase video for Group 14's Motor Assisted Cooling System. My name is David Crumley, and I was a computer engineer on the project. I was personally responsible for the motor assistance system we see here on the front of the cart. Now I'd like to hand it off to Min Park to talk about his portion of the project.
Hello, my name is Min Park. I'm also a computer engineering student, and I was responsible for designing and creating our temperature sensor and our cooling device. And now I'll pass it off to Akil and Fawn.
Hello everyone, my name is Phung Thi Young and I'm an electrical engineering on the project.
Hello, my name is Akil Ahmed and I'm a student of electrical engineering, and we both work on a solar charging circuit for our load.
So before we get into the demonstrations of our project functionalities, we would like to explain a little bit more about what our project is. So our project is a motor-assisted cooler that will provide more time for fun outdoors and less strain going back home. This project is close to home for us because we will all live in Florida, where we can enjoy fun in the sun year-round. So there are three main motivating factors which help to design our project. These factors are based on the challenges that may be faced when bringing refreshments for recreational activities. These factors are ease of mobility on most terrains. This can especially be a factor for the elderly. The second factor being that we want to make sure that whatever is in the cooler stays cool no matter what. With these two motivational factors taken care of, we can reduce at least some of the stress that can happen when you just want to have some fun in the sun. So there are four major components within the M.A.C system. Three of them have been outlined in the intro, with the fourth being the power distribution being taken care of by the whole team during the full integration of the project. So now that the explanations are out of the way, let's see these components in action. Okay, so here we can get a closer look at the motor assisted system. Within this box right here, I have a potentiometer. Out of it comes a shaft that connects to the telescopic handle. As I pull on this telescopic handle, the voltage across the potentiometer increases, telling the motor control circuit to put more voltage to the motor. If I get up and pull on it, we can see it in action. So now we just saw the motor assist system at a glance, but here we get a better look at each of the components of this part of the project. Here we can see some of the circuit. With the box open, we can also see how the motors are connected to the wheels to the belt drive.
Here we have display for our solar charging circuit, and let's turn it on. We can see how much voltage solar panel is generating and how much current is going out of solar panel. We also have the battery display and the duty cycle. Right now battery is in bulk state, so it should get as much power as it can from the solar panel, and this duty cycle will increase or decrease based on the requirement. So right now we are getting 24 watt and it should increase up to maximum value, and let's see how much it can give it us. The duty cycle is at its maximum points and we are getting power up to 36 watt, and since the battery is in bulk state, so that's why it's getting the maximum power. But with time, the duty cycle will change. Even the current going the battery will also change depending on the requirement.
But right now one of the sensor in our batteries is broken, so we already order another one and it's gonna be replaced soon with the sensor right now that we're having.
Talk about our sensor in last video, they were not working properly, so we replaced the old sensor with the new one, and as you can see we are able to get 37-38 watt from solar panel and it's charging the battery. And since the battery is in bulk or absorbed state, so it should give us more power. That's why it's running at a maximum power point tracking, but with time it reduced the current and battery state of charge will increase.
All right, now let's take a closer look at our Peltier refrigeration system. As you can see, the fans are moving because our internal temperature of the cooler is lower than our set temperature. So let's change that really fast. All right, so now the internal temperature that we set is 71, while the inside temperature of the cooler is at 75, so you can see the fans moving. So our Peltier refrigeration system consists of 2 heat sinks accompanied by 2 fans. And on the top part, you can see the fan here and a heat sink underneath this cover, which blows the air out through the heat sink to not cause our Peltier device to overheat. While on the bottom side, and on the bottom side, you can see another fan here that disperses cold air throughout our cooler. All right, so our next video is going to be a time lapse of our cooler in action. We set our temperature to 50 degrees, so we're gonna watch our cooler drop down to that temperature, as well as our charging circuit working. You'll be able to see the battery charging while the cooler is draining battery as well.
Start.
Woohoo!
See that?
It works.
All right,
Well,
let's-
we'll see if it works.
Not even doing anything. Not even barely pulling it at all.